Hey everyone, it's Eugene and welcome to another video. Today what I'm going to be doing is talking about how we can use laser scanner data inside of a photogrammetry program to improve the final meshed result. Now, a while back, I posted a short video that shows a vehicle, and I did a photogrammetry project on it and showed what the result was with a textured mesh. And there was a lot of defects, a lot of issues and things like that. And then what I did was I took a Recon 3D scan, which was more complete. So the dense point cloud was looking pretty good, but you can substitute the dense point cloud in for the dense point cloud that's created by a photogrammetry program. And in the end, you get a much better result. So that's what I want to show you today. Now, let's talk about photogrammetry for a second, because there are some things I think that we should probably put on the table here. Photogrammetry is a great technology. It's fantastic in so many different applications. People are using it for mapping roadways, for mapping evidence, a whole bunch of different things. But it has its downside. There are a number of different variables that affects the quality of a photogrammetry project. And one of those variables is the object itself. So for example, if you're doing the ground, if you're doing dirt, if you're doing asphalt, if you're doing bricks, things with a lot of random texture, it comes out fantastic. But if you're using a lot of man-made materials or man-made objects, things like shiny plastics, painted surfaces, metal, shiny polished surfaces, things like that, they never come out that great. There's always a lot of issues with the matching. And by that, what I mean is, a photogrammetry project will be looking at a pixel in one picture, and it will try to find that same pixel in another image. And if you have a shiny surface, or for example, if you have just a plain white wall that is void of any texture, it causes a lot of problems, and you just end up with either a lack of data or a lot of noise. And that's exactly what happens on these vehicle projects. So what I'm going to be doing today is I'm going to take some data from Recon 3D. So Recon 3D captures video, and it also records or gets you some point cloud data. And what we're going to do is we're going to create a photogrammetry project that's separate. And I'm going to do that with photographs, but you could also do it with the video that comes with Recon 3D, because Recon 3D records video and it has the LiDAR data, fuses them together, and then gives you a final result. So we can pull the video and extract frames, but in this particular case, I have high resolution photographs that I took, so I'm going to be using those in 3ds Zephyr. We're going to run through the project in 3ds Zephyr. I'm going to show you what the result looks like in 3ds Zephyr just on its own, just a simple photogrammetry project. But then what I'm going to do is I'm going to import the point cloud from Recon 3D and substitute it in place of the dense point cloud that was created in 3ds Zephyr, and then do the final mesh. And I think what you'll see is that you'll get a much improved surface mesh or geometry that you can texture. So it's kind of a cool little trick. You can use it in many different areas whenever something doesn't reconstruct well in photogrammetry. If you have a different way to capture the geometry, you can even 3D model it. Just do a simple 3D model and then bring that in, and then, do the same work. You would follow the same kind of workflow. So let me get 3ds Zephyr open. Let me walk through a project and we'll go from there. Okay, so I am inside of 3ds Zephyr, and we're going to just walk through a standard photogrammetry project that uses photographs, but I could use video. So let's just go through it. I'll show you what the result looks like. I'll show you where there are like defects and things like that inside of the project. Now, there are some things you could do along this project to help improve the final result, and that involves a lot of editing and cleaning up the sparse point cloud, the dense point cloud, and stuff like that. But I'm just going to run through a regular project and just show you the result, and then we'll go from there. So first things first, let's create a new project, and I'm going to go ahead and go next. And here's where I can choose to import video, or I can import photographs. Now, I already had photographs for this, so I'm going to open this up. And let me go to the desktop. I got a separate folder here, and I've got JPEG photographs. Now, I did also have frames from videos, so I could potentially just extract the video from Recon 3D. And that's great, because if you didn't take the photographs, but you want to go back and then have a better textured mesh, the texture from video is probably going to be much better than just using point cloud data itself. But let's go back to the photographs that I had. So these are a whole bunch that I took with my iPhone 15. I believe it was either a 13 or a 15, but I'm just going to add them all. So I'm going to go open, Okay, they're all there. We're going to go next. You can see here, oh, this was my 13 Pro, wasn't my 15, but it's an iPhone either way. I'm going to go next, and I'm just going to use the default settings. There's a general, default, go ahead. And I'm going to run that. It's got some GPS coordinate data. That's great. And let that do its thing. I've got 120 photographs, so there's plenty of photographs. These are higher resolution, so it is going to take a little bit more time. So I'm just going to pause here, and once it's done, we'll come back and I'll show you what the final result looks like. Okay, so it has finished the reconstruction, the sparse point cloud. And if we look through, I'm just going to scroll very quickly through all of the images. You'll see that it says yes, 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 yes. And that means that all of them have reconstructed. So we haven't lost out on any of the images. Now I'm just going to go ahead and click finish, and let's have a look at what this dense point cloud looks like. Okay, so I always look at the, sorry, I said dense point cloud. Let's have a look at the sparse point cloud. Now, let me just shut off these cameras. So right off the bat, you can see that there's a lot of points that are on the ground. Okay, this is all the asphalt that's around the vehicle. And that tells you something, and that's simply because there's a lot of features, a lot of random texture on the asphalt. So that was used for, you know, the reconstruction, and it's very, very helpful. But if you look at the surface of the vehicle itself, you know, there's a little bit over here on this side, but it's not really that dense. So what that tells me is I'm probably not going to get a lot of great data, especially looking at top down. I mean, the roof is almost void of any points, and, you know, same thing with the hood and stuff like that. Pretty sparse. So what can we do? Well, we got to just run forward with it and, you know, see what the dense reconstruction is going to look like. So I'm going to go ahead and do that right now. I'm just going to go workflow and go to the dense point cloud reconstruction. We're going to use all cameras. They were all reconstructed, and I'm just going to use the defaults once more. So let me go ahead and click run. And once again, let this run through. I'm going to pause here and we'll come back once this is completed. Okay, so it's just finished right now, all done. And I'm just going to hit finish, and let's have a look. All right, so if you look at this vehicle, this is pretty much what I would have expected. So on the top here, you can see there's not a lot of data. You know, the sides of the vehicles here, not a lot of data. And same thing with the roof. You see where there was like some writing or whatever, it was able to pick that up. But around it in these empty areas that don't have a lot of texture, it gives you some issues. So, and there's also a lot of noise. Like if you look up close here, okay, you'll see that there's a lot of points sort of floating above and below the surface. It's not the cleanest set of points. Same thing on the roof here. If I start to slowly move this around, you get a lot of noise. So this is problematic because if it's going to try and reconstruct a mesh from this point cloud, I'm going to have a lot of defects. So especially in these open areas here on the side, I'm going to run into some problems. Okay. So what I'm going to do right now is I'm going to go through the meshing process just the same, but I'm going to limit the reconstruction to just the vehicle. So I'm going to take this bounding box and I'm going to limit it here like that, just so I don't get a lot of other unnecessary meshes way out there. You know, obviously it picked up some stuff on the edges here, but I don't need that. So let's see if that's okay. Is that enough? I got a little bit more over here. I'll just shorten that down a bit. Okay, that's plenty enough for me. Like that. Okay, great. Let's just make sure the bottom isn't reconstructing. No, that's, you can see there's a lot of stuff going on there. You see I have to level the vehicle a bit. I could do that later. It's not a problem, but I'm just going to do this right now as is, like that. And let's go ahead and create a mesh. So we're going to do the mesh extraction. Again, 120 cameras. We're going to use everything. General default. Let's do it. Run. Okay, we're going to wait and see what happens here. Probably not going to be a great result. Maybe it'll be okay, but I think, you know, this will give us something. Okay, we're all done, and we're going to look at what the mesh looks like here. Okay, so we can already see we've got some problems. Okay, so there's some holes here. There was some missing data, and on the top here, we've got a big hole. And right now, we sort of have a basic texture here. It's not really pulled from the photographs. It's just sort of transferred from the vertices. So it's not that great, but you know, it doesn't look too bad really, right? It's like, hey, that's not too bad. Maybe I can repair some of this on the windshield and that sort of thing. But you'll see that there's actually more happening than meets the eye. So what I need to do is I'm going to shut off the color and I'm going to turn on this light so you get an idea of what the mesh looks like. And you can see now it's just a wobbly mess. We got a lot of defects here and here. At the back here, we've got a bunch of missing data. You know, just not all that attractive. It just looks a bit of a mess. This side, not too bad, right? We can smooth this out too. There's other things we can do. Some holes here, some defects. So it's okay, but it's not great, right? It's not impressive. You're not going to win any awards with this particular mesh. So let's, well, we can continue on and we can put the texture on here, but I think it defeats the purpose at this point. You can see that the mesh is not really all that great. I can turn on the wireframe so you can see what the wireframe looks like here for this particular mesh. And you can see it's just a big mess all over the place. Okay. And there's, like I said, there are things you could do to help improve this a little bit, but wherever you get these big gaps, unless you can fill them in somehow, then it becomes a problem. So you see we got some emptiness here and we got this big defect here as well. So let's stop here. And what we're going to do now is we're going to talk about how we can fix this with another dense point cloud. So we got to take a step back. We got to go back to our dense point cloud here, which is this guy here. So if we can improve this in the photogrammetry project, let me go back to the textured mesh. If we can, excuse me, just the colored point cloud. If we can go back to this and fill in all these gaps, reduce the noise, and then, substitute in a better point cloud, we can generate a mesh from that point cloud and get a better final result. And that's what I'm after. And this is a really simple technique that I'm showing you right now, but there are things you can do beforehand if you know that you're going to be doing this that will make it even better. Okay, so let me show you how that's done, and then we'll go from there. So the first thing I need to do is import the Recon 3D point cloud. Okay, so I've just switched screens and I'm here in Cloud Compare, and you'll see that I've got the point cloud from Recon 3D, and it's much, much cleaner. I mean, if you look at the surfaces here, the back, we don't have that defect back here. There are some little things that are missing here, a little bit of data, even up top here, but this is a world better. I mean, much, much better than what we had in the photogrammetry project. So we're going to take this point cloud and substitute it in. So let me switch back to 3ds Zephyr. Okay. And let's see what we can do here. So the first thing I need to do is I need to import a model, and I'm going to go to the desktop. I'm going to go to the Cobalt, and I'm going to go to this here. This is the Cobalt 4 E57 file. So it's just a point cloud file, and I'm going to bring it in. Now, the scale could be off. There's a whole bunch of things that can happen here. And let me talk about the process of what we need to do. So these two models, these two point clouds are going to be the photogrammetry point cloud and the Recon 3D point cloud. And they're going to be in separate coordinate systems. They're not going to be aligned. So we need to first bring them together and align them. So, and even register them together. So I know that the results from my Recon 3D are likely better. In this case, they definitely are better than the photogrammetry point cloud. So I'm going to take the photogrammetry point cloud and I'm going to register. And that means I'm going to align and scale it to the Recon 3D point cloud. And then once I've done that, I have to make the Recon 3D point cloud a structured point cloud. And what that means is that the software will recognize it with respect to the reconstructed camera position. So I have to be able to relate the Recon 3D point cloud to the photogrammetry point cloud and, basically align all the camera positions and stuff like that. And that's called structuring the point cloud. So that's what we're going to do. Now, right now, it's imported both. And you can see here, I've got Cobalt 4 unstructured. So I need to move out here and figure out where the heck this is. So let's have a look. If I go to the camera and I have to look at the Cobalt 4. Okay, there it is right there. So they are completely different spaces. Okay, so and it's a little bit hard to manage in here. But what I'm going to do is there's a registration tab here, and I'm just going to go match object center. So let me click on that. And what do I want to match? That there with all the structured objects. Okay, so now I've got something that's a little bit closer together, but definitely not aligned. And you can see right off the bat that the photogrammetry point cloud is not aligned and it's not scaled to the Recon 3D point cloud. So I need to do that. All right. So in order to do that, I have to start doing this scale, rotate, and translate. Now, there are two ways to do this, okay, this alignment. One is going to be where you create a separate project and you take the Recon 3D point cloud and you do control points. You create control points and then you do the same thing on this photogrammetry point cloud. I'm not going to use that method. It's a fairly elegant solution and it's okay, but it requires that you make a separate project with just the Recon 3D point cloud, and then you import that project in, you align the two and scale based on the point clouds. That can work pretty well. There's nothing wrong with that, and maybe in another video I may show that. But for this one here, we're going to tinker with the tools that are in the registration tab here. And so it's maybe not as elegant, but it is relatively simple, and it just takes a little bit of, a few iterations of moving things around in the coordinate space. And I'll show you how that goes here. Okay, so you're going to be just using the registration tab inside of 3ds Zephyr. So let's go scale rotate. So right now it's having me scale and rotate the 3ds Zephyr model, the photogrammetry model. I'm going to turn on the cobalt so that I can align both. I can see both, okay? So what I'm going to do first is I'm going to rotate this one around like that. So that's good. And let me rotate down like that. And then what I'm going to do is I need to scale this down. So that's down like that. And then I'm going to move this back like that. I'm going to rotate a bit, and I can see it's not exactly aligned, nor is it properly scaled. So just little by little, this is what I'm doing. I'm just kind of tweaking it in place just by using the gizmo here. I need to increase the scale a little bit. So I'm just going to do it gently over here. Oh, that's too much. Definitely too much. So let me see if I can do it a little bit more accurately here. And I also need to bring it down. I can see. So something like that. Okay. And I need to bring this up in scale like something like that. Okay, maybe. And let's see if I just put them side by side, what they look like. And you can see this is a little bit of a process here, right? Like tweaking and moving things around, trying to get it into the proper coordinate space. And for this, we just need to get it close. So I just got to get it close enough. And I try to get it, pretty close so I can see the back end is there. So maybe this is a little bit too big now. Let me go a little bit smaller. Tiny bit smaller. That's bigger. Okay, something like this. All right, and I need to move this back again. It's not perfect, okay? It's not perfect at all, but I think it's close enough. We can give this a go. Now, if this is not close enough, it may cause some problems, but I'm going to leave it here for now, like that. So the two are roughly aligned. Let me just look at it sideways here like this. Okay, so they are, it's pretty rough. I can see this one here. Now, I'm not happy with that. I can do a better job. I can do a better job. So let me go back to scale rotate, and I have to turn on the other Recon 3D point cloud, and let me get that back a bit. I need to rotate this a bit like that, and let me take it down a bit. So I can see just from here that the wheelbase is off, so I need to tweak this just a tiny bit. So let me see if I can scale this up just a tiny bit like that. Okay, and let me put that forward. I think I need to go a little bit bigger, maybe like this. Maybe, did I get it here? Okay, you can see where the tweaking and stuff like that. So that looks a little bit bigger. I'm going to see what happens with this. If it fails, I can just come back and then do it again. But I've got them relatively close together with both of them here. Okay, so now what I'm going to do is I'm going to register the two together. Okay, so this is where I have this ICP function down here. So I'm going to go ICP. And this is just the wizard that walks you through. And it says it's going to move all the structured objects, which is the photogrammetry project, to the Cobalt 4, which is the reference, which is the Recon 3D scan. Let's go ahead and do that. Now here it says, how many max iterations and stuff like that it's going to do. And it's going to do max distance point removal. Now, I was told that automatic point removal is a good way to go, and also enable the scale adjustments. So basically it'll take the photogrammetry project, and as it's aligning it to the Recon 3D model, it's actually going to scale it for me too. So it may give me a better result. Okay, so let's start from there. Let's go ahead and go next, and let's let this start. So this might take a little while, and we'll see what happens. If it fails, I can always go back, I can tweak it a bit more, and then run it again and see if I can improve the result. So I'm going to pause here, and then we'll come back and see what happens. Okay, so it's just finished, and I'm looking at the residuals here, looking at the numbers. So the Cobalt model was in meters, and this is giving me some pretty high errors. So I'm not really happy with what I got. I'm going to go ahead and finish, and let me see what this looks like Okay, so I can see it's definitely not aligned properly. So we are definitely going to do this again. And I'm going to turn the cobalt on. Let me try a different way to do this. Okay, I'm going to move this side by side. And I'm going to see if I can scale this a bit better. And I think the scaling is probably part of the issue. If I go up one notch, that looks too big. That's 1.1. So I can maybe do a little bit more finer adjustment here. Let me try half of that, like 0.5, and see what happens here. Okay. Let me go here at 0.5. Okay, not too bad. It still looks a little bit big, but maybe not. Maybe not too bad. That's not too bad. Okay, let me look at it on the side. Let me see if I'm way off here. Gotta go up a bit, no, down a bit. Okay, let me go back a bit to align the back tire, and I can see the front tire is off a bit too. It's a little bit better than before. Let me try again. Okay, that's maybe a little bit better. Let me go forward a bit. Okay. Yeah, that's not too bad. Both are in there. They're kind of sitting one on top of each other. So sometimes what you can do is you can shut things off and on. So let me take the Recon 3D scan. Okay, that looks a little bit better. It looks like it's aligned a little bit better. So I'm going to keep that. And we're going to do the ICP once more. And we're going to see if this is going to come together. So same thing. Yeah, I'm going to do that. I'll do the automatic point removal. And I'm going to go next, and let's go ahead and start. Now, it didn't take that long before, so I'll just let this run and see what happens. But the starting position between the two models is important. So if they're too far apart, the ICP just won't work really well. And sometimes you can run this more than once. Okay, now I'm looking at my results. Big difference. Okay, now before where I had like 0.15, which was like 15 centimeters, I've got 0.01, I got 0.02. Okay, so now we're talking about most of the results here falling well below a centimeter. So we're talking like millimeters over here. I can live with that, and I probably have a much better result here. Okay, and let's just double check this. I have them both on right now. I'm going to shut off. Okay, if you look there, little bit of difference between the two, but for the purposes of what we're doing here, they're fairly well aligned. And I can do more. I can keep tweaking and try to get it better and better, but we're going to leave it at that for now that it's aligned. Okay, so what that means is I'm going to shut off the dense point cloud, which is the photogrammetry model, and I'm going to just deal with the Recon 3D model. So if I go into the dense cloud here, I've got this unstructured model. I need to now make it structured. So that's pretty simple. I just got to right click, and you'll see here that it says make structured. So that's what I'm going to do. I'm going to compute colors. I'm going to use the workspace cameras because I've got all of the cameras. So it will basically be aligned to the workspace and all the cameras. And I'm going to go ahead and clone and structure. So it'll keep the original, but it will clone what I have. So just so I don't lose anything. So I'm going to go ahead and do that. Now, this does take some time, so I'm going to let this cook. I will come back and I'll show you what it gives me once it's all structured. Okay, it looks like we've got a structured model here now. We have two that are on. I'm going to shut off the unstructured, but they're basically identical. You can see the point cloud, okay, and it's just giving me the copy here. It says 2 here. Let's rename this just so we know what we're talking about here. Oops, let's try that again. Rename, and I'm going to call this Cobalt 4. This is the structured model now. Great. So now that it's structured, we can now mesh this so that you can see we've got just a basically a point cloud, right? No big deal. So let's go ahead and see what the difference is. So we're going to go ahead and workflow. We're going to go to mesh extraction. And now it says Cobalt 4 structured. That's the one that we definitely want to mesh. I'm going to go next, general default, just using the defaults, nothing fancy. We're going to run this, and now we'll see if we get an improved result. And I'll show you the difference between the two. Okay, so we finished the mesh here. Let's have a look. Oh, my bounding box was off. Got to do this again. Okay, let me show you what happened here. Not a big deal. Basically, there's something called a bounding box, and you can see that it's not even close here. What I need to do is make sure that this is aligned with the vehicle that I want to mesh. So I had that off. It wasn't aligned properly. So let me do this again. Let me rotate this and make sure that it's covering exactly what I need. And that was my bad before I forgot to adjust this. So there we go. You get to see all the flaws and all the defects and all the mistakes I make in the software. So now this is covered properly. I've got it inside the bounding box. That should be okay. Let me go back to the meshes. So mesh 2 was this terrible mess. So I don't want that. I'm just going to delete this again. We got to do it again. So let me go back to the dense point cloud. This guy here. All right. Try this again and hopefully I'll get it right this time. Mesh extraction. Yep, that one there. Use the defaults. Okay, try it again. I'll be back in a second. Okay, looks like we're back here and I've got my mesh model. Everything was working. Now, if you're wondering what happened before, there's something called a bounding box inside of 3ds Zephyr. It's this guy here. It basically tells the program to only work on anything that's inside of the box, and that just makes it more efficient. So I had moved the models during the registration, but I didn't move the bounding box. So anyway, that was a problem. Now I'm going to shut all this off. Oops. Let me try that again. I'm going to shut all this off, and now we're just going to look at the mesh here, and we can compare the two. So if I go to the meshes that I have, and what I'm going to do is I'm going to turn on a special lighting here, okay, just a single color, and you can see that I have a more complete mesh here, here, and remember at the back we had some big problems here. Let me switch back and forth. Okay, there we had some problems here. All right, this thing's really mushy. It's got some like weird stuff going on here. I just had a bunch of missing data over here. If I go back, you can see this is much cleaner. Now, there's something called what I would call the high frequency reconstruction, and that's all these little small details. Okay, so the low frequency would refer to the overall general shape, and these little fine details are like part of the high frequency reconstruction. So it's a little sensitive here, but these are things you can fix by smoothing the mesh and just going back into some of the meshing controls and making some adjustments. I'm not going to worry about that right now. Right off the bat, I can see this is a much better mesh to start with. So let me switch this off, go back to color, and now what we're going to do is we are going to create a textured mesh. So I'm going to do that for mesh 2. So I'm going to go workflow and create a textured mesh. It's got mesh 2 up here. Great. It's going to use all of the cameras. I'm going to go here and general and default single texture. So when you're texturing, you can use like a multi-texture. It'll create multiple images. For the purposes of this video, I'm just going to keep it simple and just go with a default single texture. Let me go next and let's run this. So once this is done, we'll come back and I'll have a look and show you what we got. Okay, we've just completed the textured mesh here. So I've got this here. Now when we go close, you see that we're getting some really fine details here. All right, the colors look pretty good. And if I go to the meshing, you'll see that the mesh is looking way, way better than what we had before. So that's kind of what we're after, and basically we're looking at this, comparing it to what we would get in a photogrammetry project by itself, which is this, okay, where we have all these defects, right? We got these problems back here with the mesh, okay, where we can see we got gaps, we got holes, we got all kinds of stuff going on. So basically what I've shown you, and if I summarize here, let me go back to the textured mesh. There we go, is we started off with a regular photogrammetry project on this vehicle, and we created a sparse point cloud, which was this here. Then we went through, we created a dense point cloud, which was this here. And on the photogrammetry project, you can see that it doesn't turn out all that well. Then what we did was we substituted in a Recon 3D scan, which was a more complete point cloud. And that was this guy here. Okay, there, which is a lot cleaner. And we registered it, we aligned it to the existing photogrammetry data, and then we made it structured. Okay, so this is the structured model over here. Okay, there we go. And then finally, what we did was we created a mesh, which was this here. And I can shut off the, okay, that's just the mesh. That's not the final textured mesh. And then what we did was we created the textures and applied them to the model. And that's this guy here. Okay, so now you can see it just looks a lot better. We get some pretty good details and such. So knowing this now, you can improve the mesh result by bringing in a better scan of the vehicle inside of 3ds Zephyr. Now, if I knew this from the beginning, now this is something that I wasn't planning to do originally. I just happened to have the photos and the scans. If I knew I was going to do this from the start, what I would actually do is take some other measures to improve. So for example, here on the windshield, it's possible to use, little sprays and coatings and things like that to have this reconstruct a lot better. Also, when I did this, the position of the vehicle was in one spot and then it moved and then I photographed it in another spot. So the wheels and things like that have moved, but ideally you would want to do this in the exact same position. So basically you scan it and then you photograph it, and then after you run the project, so nothing has moved completely. So if there's like little movement of the hood or the door or the wheels or something like that, that's all not going to be helpful. But overall, I think this is a cool technique. I think it's something that can be used not just for cars, but for example, it could be for other objects that give you problems with photogrammetry reconstruction. And then, maybe you can scan it another way, and then you do this little substitution trick, and then you end up with a much, much better textured model. So we're going to leave it at that. Thanks everyone. If you have any comments or anything, go ahead and put them into the comments section, and I hope to see you soon. Look out for another video. Take care. Bye-bye.